Although this is only about 6 minutes long, you may want to play it faster, so you can certainly do that in YouTube, and then my voice will sound really funny. This screencast is about horizontally launched projectiles and what we can predict about the effect of the mass, the initial horizontal velocity, and the launch height, and what that has to do with the way that projectile's trajectory behaves. Here are some important facts about projectiles. The horizontal and vertical components of a projectile are independent of one another. A projectile's horizontal motion is in dynamic equilibrium since the horizontal velocity is constant. A projectile's vertical motion is in disequilibrium since the vertical velocity will accelerate at 9.8 meters per second squared down at all times due to gravity. And the mass of a projectile does not affect the rate of descent. Not ever. Okay, if we look at this simulation, there's a red and a blue ball, and if the red and the blue ball leave the edge of the table at the same time and at the same velocity, I'd like for you to predict what you think will happen. So think about that for just a minute, keeping in mind that they are released from the same height, at the same time, and at the same horizontal velocity. Let's see what happens when they go. Well, I hope that matches with what you expected. If the balls are launched from the same height with the same velocity, they will strike the ground at the same time. So the balls strike the ground at the same place and at the same time. Now let's try this one. Now we have a red and a blue ball that leave the edge of the table at the same time. The red ball starting velocity is less than the blue ball starting velocity. So in this case, the blue ball will be coming off the table much faster. So you can imagine that the blue ball is moving really fast, whereas the red ball is moving more slowly. So I want you to predict which one will hit the ground first, or if they'll both hit the ground at the same time. Or I also want you to think about where they hit relative to the edge of the table. Will they hit the same distance from the edge of the table, or will one be farther away? Let's see what happens. Hopefully that's what you predicted. They hit the ground at the same time because they have the same vertical change in position. They're falling the same distance. But since the blue ball has a larger forward velocity, it will move farther. So the blue ball lands farther away from the edge of the table. So the balls strike the ground at the same time. The red ball strikes the ground closer to the table because its initial velocity was smaller. Okay, so now we have a red and a blue ball that leave the edge of the table at the same time and at the same velocity. And the difference now is that the red ball's mass is less than the blue ball's mass. So you need to think about what effect the mass will have on the way the ball falls. So in this case, imagine what you think will happen. Will they fall and strike the ground at the same time? Will they hit the ground in the same place? Will one of them fall faster than the other? Let's see. Oh, hopefully you weren't too surprised about that. The important thing to keep track of here is that the balls strike the ground at the same time and at the same place, and the conclusion you can draw is that mass has no effect whatsoever on the trajectory of the falling object. Very important. Mass will have no effect on the rate of descent of a falling object. Now we have two more balls. Now we have red and green, and they are on a table of two different heights. So if those two balls leave the edge of the table at the same time and at the same velocity, if the red ball starting height is greater than the green ball starting height, I would like for you to predict how they will, how their paths will look. Think about which one you think may land closer to the tables, or will they land at the same time or the same place? Oh, how interesting. The red ball and the blue ball came off the table at exactly the same time. So they both started moving at the same time. The green ball hit the ground sooner because he was closer to the ground. That should not be a big surprise. The red ball didn't hit the ground at the same time. It hit the ground later, and because it had more time to fall through the air, it moved farther away from the edge of the table. So it landed farther away from the table as well. So the red ball strikes the ground farther from the table, and the red ball strikes the ground after the blue ball. Okay, those are the big ideas. Good job, ladies.